Okay, the next two examples involve parallelogram properties, and as with all the other properties we've seen, I want you guys to have the ability to see a picture and then properties pop up in your head. So when you see this picture or this picture, these properties should show up in your head. You should just know the acute angles are equal to each other, the obtuse angles are equal to each other, any acute and obtuse adds up to 180. They're basically the same properties as a parallel lines cut by transversal. All right? With the diagonals, that's what these are called when you connect corners of any kind of polygon together, one corner to an opposite corner, that's called a diagonal. A parallelogram has exactly two diagonals, and the two diagonals in a parallelogram just happen to have this relationship. They cut each other in half. So whatever this is, that's equal to it. Whatever that is, that's equal to it. And that's the property. It's an easy property. It's simple. If this is 5, that's 5. This is 22, that's 22. That probably wouldn't be 5 and 22, but I'm just saying if it was. All right, so simple properties. And again, properties aren't difficult. The immensity of the number of properties is what's difficult. So don't just learn them for today. Get them to the point where you, again, can see the picture and those properties pop up immediately. Okay, ABCD is a parallelogram. Measure of angle BAD is 65 degrees. Whenever they name an angle with 3 letters, the middle letter represents the vertex. So when they say BAD, they're talking about this angle here, starting at B, going down to A, and coming across to D. If they say BAC, now they're talking about just this little piece. And if they say CAD, they're talking about that little piece. So anytime they use three letters to represent an angle, that's how you're going to establish where you're going from and to for this arc. So BA is this ray, AD is that ray, BAD creates that angle. That's 65 degrees. Okay. It tells me to find the measures of angle ADC. So angle ADC, again using the same 3-letter stuff, A to D to C makes this angle. And measure of angle DCB, DCB is this angle. Alright? So ignore the diagonals right now. Just focus on the green, the red, and the blue. Okay? BAD is an acute measure of 65 degrees, right? In a parallelogram, all the acute measures are the same, all the obtuse measures are the same, and acute and obtuse add up to 180. So if we're focusing on that, I know for a fact that if I take the 65 degrees that angle BAD is, and I add that to the measure of angle, they call it ADC, this red angle here, that's acute. This is obtuse. I can see with my eyes that angle is bigger than 90, right? You can always assume an acute or an obtuse when they're drawn that, obviously. Acute plus obtuse equals 180. That's the property that is given back here. Maybe. There it is. A and D would be the two that we're dealing with here. The two bottom ones add up to 180. That's all that's happening there. So if I solve this, I just got to move the 65 over here and subtract. I end up with measure of angle ADC is equal to 115 degrees. All right. Looking at angle BCD, what kind of angle is that? Or DCB, this one.
It's an acute.
That's an acute angle, and acute measures should be equal, so 65 is down here, that means 65 up here. So measure of angle DCB is equal to 65 degrees. No equation necessary, it's just the answer. I mean, you can look at the picture and you can see it. Okay? So with angles, as far as angles in a parallelogram are concerned, that's pretty much what they're going to be. If they give you one, you should be able to find all 4 of them. All right. The other question says find x and y. So if we take a look at x and y, and I'm going to erase all these angle marks in here now and focus now on the diagonals. That's another thing you have to do when you're dealing with parallelograms. They quite often put the angle questions in with the diagonal questions, so you have to kind of think of them as 2 separate problems. The angle stuff has properties, the diagonal stuff has different properties. The diagonal properties say that y plus 7, this piece, should equal 4. And x plus 2, this piece, should equal 7. The 2 pieces of the diagonals cut in half are exactly cut in half. So the pieces, so from here to here is equivalent to from here to here. So x plus 2 equals 7 is a true fact based on the fact that this is a parallelogram. And y plus 7 equals 4 is also a true fact based on the fact it's a parallelogram. and each of these equations can be solved individually. So this one's going to give me x equals 5. This one's going to give me y equals -3. Okay. Now something happened just there, y equals -3. We have a figure problem, we got a negative answer, and that should cause us to get a little queasiness in our stomach. Like, that doesn't seem reasonable. I don't like negative numbers involving figures because side measure is supposed to be positive, right? But if y is -3 and I put -3 plus 7, that equals a +4. The sides being represented by this piece here, that piece is actually positive even though y is negative. That's legal. That can happen. There's no problem with that. Okay? Everything I did on this board was all allowed to be done because of these 4 words. You know, I'm counting A, B, C, D as a word. A, B, C, D is a parallelogram. If they say those words, some figure is a parallelogram, that immediately makes all the parallelogram properties alive and well. Okay, so that's how you go about doing it. And again, once they tell you something like that, something is a square, all of a sudden all the square properties are there. Something's a right triangle, all the right triangle properties are there. So if they tell you what a figure is, that immediately opens up all the properties associated with that figure. So allow yourself to know the properties and be able to work your way through a problem like that.